Good morning, good afternoon, and good evening from my living room to yours. I am Timoni West, the Director of XR Tools at Unity, and like everyone here today watching this stream, we at Unity believe that augmented reality truly has the power to change the world around us and make computing a seamless part of our everyday lives. And we believe that one of the biggest barriers to this transition to mass AR adoption is the lack of professional-grade AR tools. Tools that allow creators to build experiences that really fulfill that promise of augmented reality, experiences that are intelligent and dynamically interact with the real world. So over the past few years, our team has been on a mission to fulfill this promise by building the tools that allow creators to make the content of the future. We want to solve the hard problems for you so that you, the creator, you can focus on really building those amazing projects. So our mixed and augmented reality studio, known as Mars, is a suite of design and simulation tools that not only make intelligent AR experiences possible, but makes making them more straightforward. Mars is the first tool set that brings together environment and sensor data into the creative workflow so that you can unlock the next generation of augmented reality experiences. And we are so excited to tell you that we're no longer just talking about these tools. We are making them available to you. The Mars Editor extension will be launching in June. Now this gets you a specialized work environment that includes the power to author, test, and deliver intelligent AR experiences in a very streamlined workflow. This work environment sits inside the Unity Core platform, and it includes simulation environments, a device view that allows you to have a what you see is what you get authoring experience, flexible layout design, and proxies that are stand-ins for real-world objects. So to show you what this looks like, I'd love to introduce Phil Chacko, our product lead, and Lewey Geselowitz, our data lead on Project Mars.
Thanks, Timoni. We're going to show you how to define content using Mars and how you can iterate very quickly using the Mars simulation environment. To start us off, we have Lewey here set up in our demo scene. Special thanks to our friends at Dr. Seuss Enterprises and Sugar Creative for these wonderful assets. We've added a few new features and windows here. What you're seeing is a simulation view, which provides a local testing environment and lets you preview how your content will appear without having to test to a device, which can become cumbersome and time-consuming. On the left-hand side, we have the Mars panel, which allows you to create proxies, replicators, and groups. New types of AR concepts that help you build your app quickly. Lewey, can you drag a camel onto the sim view? Great. Now that looks simple, but a lot is going on. Can you walk through what we just did?
Sure thing. It looks like we just dragged and dropped this camel into the scene. But as you mentioned, there's a lot that's happening under the hood. What we've done here is create a proxy as well, which is itself a combination of conditions that are flexible, like height and distance, and actions that work in the simulation view and on your device when the user is actually playing with your app. In this sense, you're not just laying out a scene, you're defining how the content gets laid out. That is essential to make sure your app works in any space.
The conditions can relate to plane size, alignment, image markers, or other types of real-world data. This is the essence of augmented reality, adding in data that really lets your app be aware and interact with the real world around you. This is what you, the app maker, need to define. Not everything about the world, but the constraints your app needs to work.
And you can tune these conditions. For example, here, I can make the size of the required plane a bit larger so that the camel has some space to move around. Now, of course, this is just one room. We need to make sure that our experience works in other environments, especially if we can't go there in person.
We need to make it easier to switch not only between the synthetic environments you see here that come with Mars, but also any scans you may have of specific physical spaces you're building for. Here's a scan from our friends at realities.io of the Memorial Garden at Civic Center in San Francisco. You see that you can still drag and drop your objects right into the scanned world. Speaking of the real world, there's another component to developing, how the device actually makes sense of the world. When people actually use AR, they have to move the device around to scan the space. This is a core part of AR. We need to replicate this functionality in the editor to help with the iteration times. We call this the sim device view. This view sits alongside the simulation environment, and when Lewey hits play, we have a new edit time mode that shows how a generic AR device would actually see the space and build up a map. So we have an edit time mode that allows you to debug using our simulation hierarchy, but here we're going to use play mode because to get forces working and have our scripts. Here in this simulation, we're now performing raycasts, constructing a point cloud, and voxelizing the space to come up with a simulated world understanding. In other words, we're having Unity pretend to be you on your phone or HMD. This is incredibly useful, especially when you can't be in the space you're developing for.
As you can see, as we move around, some of the labels for the museum are shifting. This is using a new feature called forces. This allows per frame a dynamic layout based on what the device currently knows about the space. Forces allow you to define objects relative to the space around them, an essential part of AR development.
Imagine, for example, you have a manufacturing client who needs a training app for their factory. We'll switch to the factory environment and show the training tutorial template. For this tutorial, we'll need to guide our user through the environment. In this case, we'll be using image markers.
Here's where we can easily create a proxy for a marker that the user may find in their physical world. Here we have an image marker that we see in the world. We can now create the image proxy and associate a model with that. And here we'll have an image marker library that we can use to match against the real world. I can choose from a library of known markers, as you can see here. It is associated with the same marker in this emulation view and is very easy to add a new marker simply by adding a new image. Now, if you hit play, you can actually see the tutorial roughly as it will be in the real space.
We've just barely scratched the surface of the features of Mars, so please do tune into our related talks at AWE or on the Unity site to learn more. In the meantime, we're excited to introduce Jamie Innes, product lead at Fictioneers, who is here to talk about their brand new augmented reality story for the classic UK stop motion cartoon, Wallace and Gromit, made exclusively using Mars. Let's roll the clip.
By heck, Gromit, these job orders are really taking the biscuit. To the spick and span mobile. If we're going to fix up a whole city, we're going to need a recruitment drive. Step on it, Gromit. There's not a moment to lose. The big fix-up needs your help. Get cracking.
Hello, welcome. I'm Jamie Innes, Creative Product Lead at Fictioneers, a joint venture of Potato, Sugar Creative and Tiny Rebel Games, working with the University of South Wales. We won an Innovate UK Audience of the Future grant to create the future of the moving image. Our mission is to use leading technologies from Unity combined with traditional storytelling capabilities to deliver new and exciting augmented stories in real time using our storytelling platform. Since last year, we've been working with our award-winning partner, Aardman, to craft Wallace and Gromit, The Big Fix-Up. It's a collaborative, experimental project exploring innovative and accessible ways of telling and augmenting stories. The Big Fix-Up is Wallace and Gromit's first foray into augmented reality with this brand new adventure. And for the first time, the audience gets to join in. The story will play out in real time over a period of about a month, combining beloved and new characters, comedy and charm, along with a number of groundbreaking entertainment technological firsts. Our goal is to immerse the user into the Wallace and Gromit world, to make the journey engaging, playful and fun, and to make it accessible for fans of all ages. As an employee of Wallace's new company, Spick and Spanners, you get to experience the entire adventure from the comfort of your own home. Here are 2 examples of the many odd jobs which Wallace will ask you, as one of his employees, to undertake. To create engaging experiences like this, we're using Unity's AR Foundation packages and visual positioning systems, while other experiences utilizing the power of Mars. The Big Fix-Up, played out in real time, will allow the audience to interact with Wallace and Gromit and various contraptions. The story will play out in a variety of different medias to tell the beats of the story, from multi-user AR gameplay, introducing new CG animations, in-character phone calls, comic strips, XR portals, and many more. All brought together in a mobile app, used as a window into their world. The project has a very heavy and important research focus. So from the very start, it was vital for us to find the most cutting-edge AR technologies. We started working with the Mars team last summer. We quickly realized that this was a critical piece of technology which we could use to help tell the story. The Mars team has been incredibly helpful and hands-on in their support of our project, even during the intensity of COVID the last few months. With Unity's AR toolkit, we are able to achieve this by bringing beloved characters into our world. With Mars, we're able to give these characters intelligent, dynamic behavior. Using the Mars reasoning systems, the placement of AR content can be automated. Mars finds the most appropriate content to place in the user's space based on the constraints attached to the object and the space available. We can author unique moments with our star key characters from our story and make those characters spatially aware. It's delightful to watch these characters come to life around your home. From a development angle, using the Mars simulation view, we're able to quickly iterate content while testing it in a variety of unique environments, all without making a single build. Once we are certain the characters and contraptions are reacting in the way we expect, we can then build the project and bring them into our world. Contraptions created by our users can now traverse the surfaces of your home. They can hide under your coffee table using the dynamic navigation meshes and occlusion planes provided through Mars. So as you can see, Mars has truly been a marvelous tool for us to use for the Big Fix-Up. Chacko Creative will be talking further about their experiences with Mars in the developer talks just after this keynote. The Big Fix-Up will launch first in the UK in autumn this year, with plans to roll out that release more broadly. You are invited to take part in the story, to experience great characters, humour and storytelling, all brought to life using technologies such as Unity Mars. For Fictioneers, this is our first bold step in our mission to create what we call augmented stories, taking audiences on real-time interactive narrative journeys. Harnessing Unity's power, we are creating a new set of tools to empower creators to tell stories in a way which hasn't been possible before. Thank you from Fictioneers.
Thank you so much. So as you can see, Mars is really first of its kind. What we're doing is delivering a whole new framework for creating augmented reality. We want to give you time to dig into it, ramp up, and see for yourself how much this will fundamentally not only change how you make augmented reality experiences, but really also elevate that quality bar quickly so you can build what you really want to build. And because these are brand new concepts and workflows, and time is our most precious asset, we have created the Mars starter templates. They are pre-designed building blocks that help you save time and start customizing right away, so you can spend less time learning and more time just getting your job done. No matter what the size or scope is of your project, laying out a museum, building out a factory tutorial, bringing a beloved children's television show to life, Mars lets you quickly create and deliver AR experiences of all kinds to help you achieve your creative vision. You can get started with Mars on unity.com/Mars. We cannot wait to see what you build with this. Thank you.
That was fantastic, and I'm seeing so much excitement in the feed from everyone. Cannot wait to get into Mars and start working with it. So we have time for one quick question, and are you able to share anything about how the tracking or anchors work in Mars?
Yeah, so Unity doesn't provide its own tracking technology. So what we do is allow you to go through both XR SDK integrations and AR Foundation to use the platform-specific tracking technology. Lewey or Phil, do you wanna add any detail to that?
Yeah, effectively, we offer semantic matching over the existing tracking objects. So our hope is that you can use actually a wide a variety of different tracking sources, and that at an app, level, it'll just be automatically, compatible with them, and you can easily add your own. So it's really about trying to separate the content layer from the services layer and make it easy to use lots of different ones.
That's fantastic. Thank you so much. Great panel, lots of excitement around this. And I believe we'll see you on another panel a little bit later. So hopefully you can address some further questions, but we have to move on to our next speaker now. Thanks, everyone.
Thank you so much.